Okay, so for section 3.5, you're going to want to have that paper from 3.4 to be able to do these, because it's going to be all these transformations, slides, flips, and rotations of these functions. So be sure you have this paper out and then print out the transformations on graphs paper that I have. What I want you to know or notice on this is that if you're adding or subtracting on the outside, it's going to be vertical. If you're adding or subtracting on the inside, it's going to be horizontal. And then if it's multiplying, it's going to be a stretch or a compression. And then we have our reflections. So keep that in mind as we do this. So if you've looked at the problem set, you've noticed that there's a few questions over matching. And this first one, when we look at that, the first thing I want you to do is determine which function is it most like that's on that paper. So looking at it, it's most like this square function. So I'm going to have x squared. It's upside down, so it'd be negative. And then it's not at the origin, it's at +2. This is the graph of x squared. It has been moved from the origin right to, when we move left or right, we do it on the inside, so we'd have x subtract 2 squared. Because keep in mind when you're doing these, right is subtract and left is add. So these are opposites. These on the bottom are different graphs. They're not squares. They are absolute values. So I know that this is the absolute value of x. This is upside down, so it'd be negative. And then it moved to the left. 1, 2, 3, 4. And that would go on the inside. So, and left is +4. Over here we went up, so 1, 2, 3, 4, and that would be on the outside. So we have the absolute value of x, it's upside down, so negative +4.